Okay. Now let's look at the first property. We will start from beginning. And I'm hoping all of you pay attention. What are we doing today? The properties of logarithm. What is the first property? We call that inverse property. Of logarithm. Yesterday you had a test, and we do have a problem, which is 7 and then log to the base 7, 49. Remember this problem? Yes? Can you tell me what is the answer? 49. Thank you. What did we explain yesterday? We say, well, 49 is the input, right? And then what do you do first? 49 go into the function, and that function is log to the base 7 x. So actually you will get the output 2, because log to the base 7 of 49 is 2, right? And then you are going to have the output as input for its inverse function. And its inverse function is exponential with the same base, that is base 7 to the power x. So 2 is going to go through this inverse function, which is exponential. So 2 as the input to this exponential, 7 to the power 2, what do you get? 49. So you start with 49, go to log to the base 7 of 49, and then take the inverse train back, you will come back to 49. This is what we call inverse property. And in general, we have this. Remember? F composed with F inverse of x is x, right? Yes or no? Yes. So we can look at differently. If I start with the exponential function, okay? All right, so I start with the exponential function. So let me say this is exponential function a to the x, okay? So the input is x, the output is a to the x. After I get that, I'm going to take log, so its inverse will be log with the same base a. So this is log to the base a of a to the power x. They have the same base. With the same base, the log and exponential are inverses. So what do you get? Tell me. It should be x. Is that right?
What if there's a number outside there?
Outside where?
Outside the parentheses.
Outside the parentheses here?
No, up in the corner of it.
Here?
There you go.
There's an exponent on the outside of the parentheses.
Oh, you mean here I have another?
Yeah. So you add it to the exponent x, and then that would equal to the product. I don't know.
Yeah, sure. This is actually, I think you are thinking about this power rule, yeah?
No, I'm not thinking about that. I'm just saying what would happen if there was like a number right up there. in the
Okay.
top
Okay.
Yeah, that's
Okay.
exponent.
All right. Let's. I will keep it here. Okay. What if log a, and because I want to say something before I answer this question. Okay, you have a exponent outside the parentheses. Is that what you're asking?
Right.
Okay, and you're asking me what is this, right? Anybody can answer this question. Yes. X to the second power? Okay, so part A, multiple choice, x to the second power. Okay. What? 2x. Okay. 2x. Any more? Okay, part C, just 2.
X plus 2.
Oh, part D, x plus 2. I hope when I give you quiz tomorrow, you will give only one answer, okay? Yes, you are awesome. Isn't just this? Okay, you know what? Let me tell you. Even though this is, we call inverses, so we can have this inverse property, can we also use this? Yes. So, you know, we can look at this as inverse. They are inverse of each other, right? So, you get that. Am I correct? Okay. But we can also use the power rule, okay, to solve it. How? See, this is log to the base A, okay, and then A to the power X. So what is the power here? X. Nathan, we need your help. Nathan, we need that music. This is the power, okay? Can we use the power rule of log? Yes or no? Yes, so you will come out. So what do you get? You get x times log to the base A of A. What is log to the base A of A? Log to the base A of A is what? 1, because A to the power 1 is A. Is that right? Log give us the exponent, right? That means, what? This is base what? This is base A, right? When the base is A, the exponent is 1. A to the power 1, you give A. Okay, oh, now people having this. All right, my bad. Okay. What is that? Log to the base A of A is what? 1. Because what? Write this in a exponential form. You will say the base is A. What power? Give me A. What is this? 1. So this is 1, right? We bypass this because we have learned this in the previous unit. But I should have mentioned this before I go into these rules. Okay, so let me add this here. Log A, log to the base A of 1 is what? 0. Because there's A to the power 0 give you 1. Is that okay? These two we already learned for 2 weeks. Okay? Log to the base A of 1 is 0. Log A of A is 1. You say, well, Dr. Chen, why? Remember the graph of log? The graph of log? Okay, if this is log to the base 2 of x, when it is 1, when x equal to 1, it is 0, remember? When x equal to 2, it is 1. Remember that? You get this. Yes? Yeah? Yes or no? Yes. Right? These are the two famous points, right? For logarithm. Am I correct? Now, we can use the power rule to solve this. So, back to Nathan's question. Sean's question. Okay. All right. Nathan, help us. Continue. Log to the base A of A is what?
1.
1. So this is what? Just x. right? Is that just x? Isn't that the same? Isn't that the same? Yes? Yes or no? Yes, right? So you can look at this as inverse property, or you can look at it by using the product rule. Now back to Sean's question. Sean's question is, everybody, what is this? So let's do it. Well, first of all, let's take care of this exponential expression. Log to the power x and then square means what? Log to the power x times, a to the power x times a to the power x, and that is what? A to the power 2x. This is power of power, right? Is this power of power? So you would have, you copy down log to the base a. This is a to the power 2x. Is it okay, Sean? What is the rule that I'm using? I'm using this rule, right? This is power of power, right? This is power of power. So it becomes a to the power 2x. You multiply the power. Power of power rule. You multiply the power. Is that okay? All right, so now the power becomes 2x, right? Can we use this power rule? So Nathan, we need your music. Come out, right? So what you get? You get 2x times log to the base a of a. What is log to the base a of a? Thank you. So my friend, what do you get? 2x. What is the right answer? B. Thomas get 2x. Okay, your group. Is that okay? Extra credit? All right. Okay, so isn't this nice? When you have the pre-reading, we can have this kind of interactive discussion, you know? Okay, next property. What is next property? The next property, we are going to talk about the product rule of logarithm. Okay? All right. Means what? Means if I have a product, m times n. All right, so I'm going to take log of a product. That's what it means. I have a product, okay? I multiply them, m times n. Now I'm going to take a log. What is that? You will become log m. Nathan. I don't blame you. Actually, I appreciate. Because I haven't explained. How could you know, right? It's not fair that I ask you without telling you why, right? Okay? Here you can use any base. So let's put the base b. Whatever base, it's okay. But they must have the same base, right? So the whole idea is if you have a product and you are going to take a log, it's going to become this. Y. Big Y. You say, because Dr. Chen said that. That's not a good reason. We have to prove it. Tomorrow when you come in, I'm going to test you this proof. You have to write it down because your textbook did not really explain. This is a part I don't like this textbook. Okay? And it doesn't explain. So you and me, we are not memorizing machine, right? Just memorizing. You have to really understand. Okay, let's understand it. How can we understand this? Now I have to think. Okay? I have to let you know I also need to think. It's not that out of my head. I have to think, how do I do this? This is not trivial. And most of the teachers have no time to explain this, or they would think that if even I explain it, people will not care or not understand. I know you would understand, right? Okay, let's work together. Can I call this number by a variable? Yes or no? Yeah, of course. Name it. And I call this by another variable. Okay, give me a name of the variable that you like. Can I use A or can I use B again? No, because I already have B to be my base, right? So let's use something different. Can I say this is X? Can I say that is Y? For example. So you say, write it down because tomorrow you are going to have this exact problem, okay? Tomorrow you are going to prove this product rule. So let X equals to log to the base B of n. Let Y equals to log to the base B of n. So I let this to be X and let this to be Y. Now, Nathan, can you help us? This is a log expression. Can you tell me how do I write this in exponential expression? Okay. Itzo, can you? What is the base? B. What is exponent? X. Great. So, that means B to the power X equals to M. Am I correct? What about for the second one? That means what? B to the power Y equals to what? N. Is this hard to you? No. It's okay, right? Ah, now I see M. What is M? Tell me, what is M? B to the X. Great. What is N? B to the Y. Great. What I'm trying to do? I'm trying to have M times what? N. Okay, let's time it. M times N. All right, now this is very straightforward. What is M? B to the X. What is N? B to the Y. Are you with me? Okay, do they have the same base B? Yes. Now, when you multiply something with the same base, you add the exponent. Thank you. What is your name? Extra point. B to what power? X plus Y. You are all awesome. Is this hard to you? No. See? I know. You can get it. So far, so good? No. B is B. Only when there's nothing that is base 10. But right now, I give a symbol for the base. Yeah, B may be 10. But B may be anything but not 1 or negative number. Oh, no, only when you don't write that. Yeah.
What is log delta?
Here?
Oh, so just, but log just disappeared, right?
Say it again.
Log? No, not what it means. Where does it go?
Oh, where does it go?
Yeah, it's not there anymore.
Oh, you know what? Remember yesterday there's one problem? We asked that if this is an expression, can you write the equivalent exponential expression? Okay?
Then you just don't write log.
You don't need to write log because this is exponential expression. This is a log expression. They are equivalent. When you say this, that means this. For example, okay, 2 to the power 3 is 8. Okay? I can write in the log, say log to the base 2 of 8 is 3. Okay? You can do it back and forth. All right? So far, so good, my friend? Okay. Now, everybody, look. Left side equals to the right side. Left side equals to the right side. Okay? I'm going to do the same action on both sides. What I try to take, tell me. What I'm trying to do. Take what? Log, right? Do you see what I'm saying? Okay, let's go back. Let's go back. What is the original goal that we have? Give me a product. I'm going to take log. Is that right? Okay, now I have a product, and I want to take log. And this equal to that. So I'm going to take log, okay? You take log on both sides. Are you with me? All right. So let's take log on both sides. So log, and then I would say the base is b. So log to the base b, and on the right side also log to the base b. So I'm going to take log to the base b of the left side, and that should equal to log to the base b of my right side. Does it make sense? So what is on the left side? It's m times n, right? What is on my right side? It's b to the power what? X plus y. Yes or no? Yes. Okay, very good. Let me rewind a little bit, just to make sure that you all get it. Okay? We start with what is x, what is y, and we write it in the equivalent exponential form. Now I multiply m and n, because that's what I'm doing. And I get this is equal to b to the power x plus y. Now at both sides, I take log to the base b. It's fair, right? Now, Nathan, we need your music again. What part is do?
Where you move it to the front.
What move to the front?
X plus y.
Because that is your what? Power. What is the rule that you use? The power rule. The power rule, so by using the power rule, okay, by the power rule of log, right, we can have the power, which is x plus y, go outside. So you would have x plus y and then log to the base b of b. Does it make sense? Okay, now Nathan, what is base to the base b of b?
1.
Great job. This is 1. Right? So what do you get? It is x plus y. You are awesome. But Nathan, what is x? Nathan, what is x? What is x? Log to the base b of m. What is y? Log to the base b of n. So isn't that right? So this is log to the base b of m plus log to the base b of n. Are you with me? What did we do? We proved, or you proved, log to the base b of a product equals to the sum of logs. Is that okay? So people usually say log of a product equals to the sum of several logs. Okay, this is how people say. How people say? People say log of a product is the sum of logs. That's how people say it. Okay? Log of a product is the sum of 2 logs. Does it make sense to you guys? Can you see? Okay? This is a log of a product equals to the sum of 2 logs. It could be 3. So let's see. Example 1. Log, okay, now be with me, log of 3x squared y. What is the base you like? Which base, what is the number that you would like to use for base?
3.
Oh, you like 3. That is a great number. So who would like to be the first one? This is what? Log of a product of several factors, right? So it will become what? Log 3 of 3 plus log 3 of x squared plus log 3 of y. Are you with me? Log of a product is sum of several logs. Is that okay? Not just 2, right? It's just like this. You can keep writing it as a product. Is that okay? All right, so Nathan, what is log to the base 3 of 3?
1.
Great job. So it is 1 plus, now you have this exponent 2, that is a power 2. So what is the property you will use? The power rule. So your music. Okay, so you will have 2 log to the base 3 of x. Yeah? And then plus what? Log 3y. Log to the base 3 of y. Is that okay? Pretty cool, huh? Okay. Perfect. Is that perfect? What? You have to leave the 1 here. Oh. Can I simplify further? Can, yeah? Yeah? Who say yeah? Product rule. Well, product rule, you must have a product within the log, but no more. This is a single log, right? Oh, wait a second. Now you have to identify. Is that single log? Yeah, single log. Single log, right? You cannot go further. Can I add 1 with 2? No. Sorry. This is a product. This is a multiplication. They would do together, right? So that's it. This is my final solution.
Can you put that back really quick? Thank you. Okay.
Is that okay? All right. Now, we have to get the next one done before you go home. Okay, which is the what? Quotient rule. What? The quotient rule. No. The quotient rule. Okay? The quotient rule. Let me tell you, that means what? Give me a quotient. What do you mean by a quotient? A quotient rule is what? Is a quotient. This is a quotient. Is this a quotient? And I'm going to take what? Log. Say I'm going to take log to the base b. And we would like to find out what is that. What is that? We are going to find out. You can prove it when you go home, okay? We will not prove because today we don't have enough time. But you are going to see that it's becoming the difference of logs. Okay? For the product, log of a product is a sum of logs. Log of a quotient, it is what? A difference of logs. Okay? Tomorrow, I'm testing you the product, okay? Do it yourself. Okay, now the problem here is you have to be very careful. You have to be very careful. Log to the base b. So let me see if you have 25x cubed over y z squared. How would you do? Log to the base b, and then this one, right? So you will have 25x cubed minus log to the base b y z squared. Yeah? Okay, and then what? Product rule here, right? Okay, so what is this? Log b 25 plus log to the base b x cubed minus log to the base b y plus log to the base b z squared. Okay, I will pause here and I'm asking a question. How many of you got this? Raise your hand. How many of you did not get this? Raise your hand. So what did you get? If you don't get this, what do you get? What did you get? Oh, okay. And let me tell you, this is wrong. It should be minus. Why? Because when you have a product, you will have sum of the logs. So you are subtracting the whole thing. So if you are going to separate them, you need to have minus here. All right, so let me tell you. You should have log to the base b 25 plus log to the base b x cubed. This is the first term. Am I correct? Minus the second big term is log to the base b y plus log to the base b z squared. You need to put the parentheses because you are subtracting the whole thing.
Under the original problem, is that z to what power is that? All the way back to the beginning. Log b to the base b 25x cubed over y. Is that it too?
This is 2.
Okay.
Yeah. This is 2. Okay? So, look, this is a subtraction of the whole sum. So you need to what? Distribute it. Therefore, you have minus log to the base b y minus log to the base b z squared. Okay. I can tell 90% will have this common mistake. What should we do?
Always use parentheses.
Okay, that's a good strategy. Or, and I want to share this secret with all of you, and this helps so many students, is writing this as a product. Because people do not make mistakes with product, but people make mistakes with quotient. Okay? So, what should we do? So people suggest that, can you write this? Okay, this is 25x cubed over yz squared. Can I write this as a product? I say, yes, it is 25 times x cubed times what? Y to what power? -1, right? Times z to what power? -2. You are awesome. What did I do? I tried to write this quotient as a product. Okay? So, because you have a product, so you will become what? Sum of logs. Am I correct? Yes or no? Yes. So you will have log base b 25 plus log to the base b x cubed plus log to the base b y to the power -1 plus log to the base b z to the power -2. Right? Because it's a product, so I just keep adding. Am I correct? Are you with me? Now I can use the power rule. Nathan, your music will start. First of all, 25 is what? 5 squared. Can I change 25 to 5 squared? Yes. Okay, let me change here. Okay? Yeah. Yes. So the 2 would come out as a factor. 3 would come out as a factor. How about here? Negative 1 will come out as a factor, right? As a coefficient, if you would like to think. How about here? This is the power negative 2 will come out as a coefficient. Is that okay? So, come out. Come out. So what do you have? You have 2 log to the base b 5, and then plus what? Plus 3 log to the base b x, and then minus log to the base b y, and then minus 2 log to the base b z. Okay? See, by doing this, you will not mess up with this sign. So, many people try to change a quotient to a product and apply the product rule. Does it make sense to you guys? Okay. So, I think you are done except the change base. We will continue tomorrow. And then the homework today will be 8.4 My Math Lab. Okay? Do I make it clear? Okay, I will put it up. There's a pre-reading that I want you to do. Is that clear to all of you? It will be from the other chapter, not 8.5. We will do a good job for 8.4. And there's one pre-reading. I will put on the canvas later today. All right? But 8.4, My Math Lab homework due tomorrow. No change base. No change base. Just the rest. Try to do your best. I want to see it, but I will not collect it. You are going to take it back. But I want to give you a quiz tomorrow. Is that okay? All right. You need to keep up your homework every day. Oh, yeah, the pre-reading. I'm collecting your pre-reading. Pass your pre-reading to me.